I'm going to be doing chapter 13, problem 20. So it says that given that the period of the moon's orbit about the Earth is 27.32 days and the nearly constant distance between the center of the Earth and the center of the moon is 3.84 times 10 to the 8th meters, use equation 13.8 to calculate the mass of the Earth. Why is the value you calculate a bit too large? So first let's draw a diagram. This is the Earth, and we'll just set it as mass 1, and this is the moon. We'll set it as mass 2. The distance between their centers is 3.84 times 10 to the 8th meters. And the period of the moon's orbit is 27.32 days. If you convert that to seconds, it's 236,04448 seconds. So it says to use equation 13.8 to calculate the mass of the Earth. So equation 13.8 is derived from Kepler's third law. And we can derive it by doing this. Here, this is acceleration. And here we can substitute centripetal acceleration is v squared over r, and 2v squared over r equal to g m1 m2 over r squared. Here we can substitute that v is equal to 2 pi r over t and get m2 2 pi r t squared. And this is moving some things around. R squared equal to g m1 m2 r. When I say r, it's all the same r's. And then square this. M2 4 pi squared r squared t squared. R squared is equal to g m1 m2 r. And then here we get the period squared is equal to 4 pi squared g m r squared, which is how you get equation 13.8. So then we're going to use this to calculate the mass of the Earth. So t squared is equal to 4 pi squared over g m2 r cubed. Move this over. The mass of the Earth is equal to 4 pi squared over g t squared r cubed. 4 pi squared, constant g. We already found the period in seconds here, so 236,04448 seconds squared. Radius 3.84 times 10 to the 8th meters squared. And put this into your calculator and you'll get 6.05 times 10 to the 24th kilograms. So if you look up the actual mass of the Earth, it is 5.98 times 10 to the 24th kilograms. And the difference between these two values is because the orbit around the Earth is not purely circular, so the radius changes and isn't constant. So this value down here changes, and that is why there is the difference between the two masses, the mass that you calculated and the actual mass.